All right. Hello, everybody. Welcome to the Happy New Year, I guess, because we didn't see this year each other. So it's going to be our first meeting of the year. And let me share the screen. This is going to be the plan for today. We're going to start, as usual, with Gazebo talking about the announcements. There's many things going on today. And then we're going to have our guest, Samuel Milan Norman from the Cardiff Computational Robotics Team, talking about Gazebo migration. This is a hot topic, I guess, this month, because we're at the end of life of Gazebo Classic. Well, I think we're going to have plenty of time for questions. So, yeah, don't be shy. And Adisu, are you ready? All right, all yours.
All right, thanks, Carlos. Welcome, everybody. We'll start off with the end of life announcements. As you see there, Gazebo Garden has. Oh, you changed your tab, I think. There we go. Okay. Gazebo Garden has reached end of life, and Citadel has reached end of life. I think Citadel was the first LTS for the new Gazebo, so that's a milestone. And then the big one is Gazebo Classic. Will reach end of life in a couple of days. We'll be sending out an announcement with the final post. Yeah, there's warnings on every, on the website, on the actual application itself. So hopefully people are thinking about migrating. If you're still struggling with that, please let us know and post on Discourse and see if we can help in any way. The other bit of news, technical-wise, SD format is now supported in ROS2 control and GZ ROS2 control. That means you can start using SDF files to describe your robot and have it work both in ROS and Gazebo without having to need a URDF file. So you can just keep one file that describes your robot. And this used to work for other projects, but now ROS2 control is also supported. Next one is ROS-GZ Sim demos has been updated. So in the past couple of months, we've been improving the launch files in ROS-GZ. We've been making performance improvements for the bridge, but the demos were still using the old techniques, and so now they've all been updated. Thanks, Carlos, for all the work. But now you can use those as examples to build your projects. And then next up is we have a new proposal for standardizing simulation interfaces that's been started by Adam Dabrowski. This is kind of just for everyone's awareness that hopefully once this gets merged, we're hoping that this will become a standard interface for all simulators so that it's would be easy for switching between simulators and having a well-documented interface for all simulators. If you have any input on any of this, the pull request is still open, so feel free to chime in. Next is we now have, as you know, we have the Gazebo Project Management Committee meetings on Mondays. The news is that the minutes or the summaries of those minutes are now being posted on the Gazebo community discourse. So yeah, this is just, if you are not able to attend those meetings, hopefully this will give you a snapshot of what happened each week. All right, lastly, this is a new year, so I thought it would be good to remind everyone that we really need everyone's help. If you have a cool project, we've added a new page to the gazebosim.org/docs page so that you can share your project. Carlos, if you can click on that. Yeah, that one. Right now, it's just bare bones. There's not a whole lot, but we're hoping for everyone to just contribute and share your cool projects, plugins. We can add more sections if need be. Just wanted to make a resource for everyone to find inspiration. And then yeah, we want your help in contributing to Gazebo. Don't don't feel intimidated or shy to contribute. We really want your help. We have a list of good first issues to get your feet wet, and we also have help wanted issues, which are a little bit more, need a little bit more experience, but not too crazy. And we're here to help. But these are issues that the core team is not going to work on in the near term. So if you have time to look at those, that would be amazing. And we're always looking for documentation and tutorial contributions as well. So please, we ask you that to consider contributing. And then there's a contribution guide at the end there that has a lot of information about how to get started. So that's all I had.
Thanks, Adiso. Yeah, so feel free to contribute. We love it. Next stop is the talk from our guest, Samuel. Hopefully you pronounce your name properly.
Yeah, it's Samuel or Samuel or either way, it's okay.
Samuel, okay. The name looks Spanish, but then maybe different. I think we're going to have a topic about migration. So hopefully Samuel will give us the pain points and frictions. And I think in this case, it's a migration from an Ignition Gazebo version to a Harmonic. So he'll go over all the adventures doing that migration. So whenever you're ready, Samuel.
All right. Sure. Is my screen sharing?
Not yet.
I see it on my end.
Your screen is shared, but it's infinite us. Oh,
there you go.
There we go.
Oh, sorry.
Yep, that's good.
All right. Hello. My name is Samuel Millán Norman. I'm a PhD student at Cardiff University and also part of Cardiff University Computational Robotics Team, also known as CUCR. And today at the Gazebo community meeting, we would like to present the migration of Stretch Robot to Gazebo Sim Harmonic. So, who are we? Who is Cardiff University Computational Robotics Team? Well, CUCR team is made of 4 staff members, 6 PhD students, and 1 undergraduate student. And what do we do? Well, apart from the information that is in the screen, I would like to think that we enjoy doing robotics in manipulation and navigation scenarios, mainly dealing with the development of autonomous systems. And well, one of the main lines of research here at Cardiff University within the robotics in the computer science department is social robot navigation, in which, as shown here, we not only develop, but we also publish within this topic. For this, we utilize a Gazebo Classic, as seen here, with the use of Pet Sim Simulator to simulate social agents within the scenario. And in this case, we utilize a hospital environment, in which, on top of this simulation that we built, we utilize benchmarks, which, for example, in this case, we utilize a state-of-the-art approach in social force model, and additionally, a state-of-the-art approach in deep reinforcement learning. Apart from being able to implement state-of-the-art models, we also generate new state-of-the-art approaches in which we contribute to the literature. For example, within this ICRO 2023 paper developed by Steven Silva here at Cardiff University, in which their multi-layer planner incorporated with a cost map compared to the different approaches that there are here, such as the social force model, which suffers of local minima, same as the deep reinforcement learning approach. Our approach, without a social heat map, well, it also suffers from similar issues, but with our new approach, with the social heat map, it solves these issues and manages to sort of make it work correctly. And the reason why I say this is because within this paper, the use of simulation Gazebo Classic enabled us to be able to deploy faster and sort of test correctly before deploying it in real-world environments. As seen here, we test the robot in a real-world environment, utilizing the Pepper robot. And if anyone has used the Pepper robot, they'll know the difficulties that it comes when trying to use it with ROS. And at that time, the Stretch 2 robot went into market, and following the advertisement and looking after several meetings within the CUCR team, looking into the different proprietary software that they provided in GitHub repositories. Well, long story short, at the end, Cardiff University ended up buying the Stretch 2 robot, which within their proprietary open source software, they had a simulation in Gazebo Classic of the Stretch robot, as seen in the screen, which we implemented into our laptops. Very easy to use, worked straight out of the box. It was fantastic, and enabled us to build on top, where based on the ICRO 2023 paper mentioned previously, we incorporated that into the Stretch robot, as seen here, and additionally modified the environment to utilize a museum environment with PetSim to simulate the social agents. And well, this is a small demo of it working in Gazebo Classic. But okay, this comes to the question of why migrate the Stretch robot to Gazebo Sim Harmonic if there's already a simulation in Gazebo Classic, and also a simulation in Ignition Gazebo developed by PickNik Robotics in collaboration with Hello Robot. The reason, after sitting down within the team through a discussion of 6 different months, of 6 months within different meetings, 2 main topics came in conversation, which was the transition of ROS 2. Why should we use ROS 2 if we already have a simulation that works in Gazebo Classic and uses ROS 1? The conclusion that we obtained from different conversations was that we should migrate to ROS 2 because it utilizes because of the real-time control it has over the ROS 2 middleware compared to ROS 1, and also the reliability that has compared to ROS 1. Another topic of interest that was in conversation was which Gazebo simulation should we use? Should we transition to Gazebo Ignition? Should we transition to Gazebo Sim Harmonic? Well, we started looking through the internet. We started gathering information, and we came across the simulation that in Ignition Gazebo of the Stretch robot, developed by PickNik Robotics in collaboration with Hello Robot, where not only they put the robot into the simulation, but they developed demonstrations such as the one seen here of a pick and place, utilizing Move It, which is also developed by PickNik Robotics, which still amazes me how it works, and it works really good. And well, after several discussions that we had, I remember vividly there was this day where within this meeting, we all opened the laptop. We searched into the Gazebo website. We opened into the distributions and started looking at the end of life of the different Gazebo versions. We came across that the end of life of Ignition Gazebo was September 2026, and the end of life of Gazebo Sim Harmonic was September 2028. And thus, this concluded that we should move to Gazebo Sim Harmonic instead of utilizing the PickNik Robotics implementation, only because we will have to migrate again the next year. Looking into the implementation that PickNik did, well, they utilized the SDF format, although we had to redo it for Gazebo Ignition, for Gazebo Sim Harmonic. We also had in consideration the use of URTF. However, since the proprietary XML format of Gazebo is SDF, we inclined into using this format, also following the steps of PickNik Robotics. So, testing the implementation of PickNik Robotics migrated into Gazebo Sim. For this, we modified the plugins accordingly by the dependencies that were provided and the documentation provided by Gazebo. We also modified the sensors, trying to simulate them as much as possible to the examples provided by Gazebo. And additionally, we went into the launch file and remodified the Gazebo bridge so that it would communicate properly between ROS and Gazebo. And we tested it, we saved it, we compiled it, and we pressed enter, and suddenly it appears in the screen, and we are like, it works. Yes, this is what we want. However, of course, there are some discrepancies between different versions of Gazebo, and well, when we tested it, when we were teleoperating it, this is the result that we obtained when we migrated robot to Gazebo Sim Harmonic. So based on visual observations, we ended up with the conclusion that it was either had to do with the center of gravity of the robot was too high, that was making the robot fall, or it was the inertia of the robot that had to be remodified accordingly for it sort of to work. And we digged into the code in which we remodified the inertias of the robot, as seen here. And additionally, we try to follow the original implementation of Hello Robot, in which and also the extractor file, in which instead of having the base link containing the STL files of the lift, the head, and the speakers, we broke it down, and we had a base link where we had the mobile base and also the Aruco markers, which are sort of there. Another link specific for the lift, and another specific link for the head containing the speakers too. We compiled it, we tested it, and finally it worked. We tested it, and it seemed it seemed robust enough to be able to sort of try to open source it. So we decided to sort of showcase it here with some demos. So we used a demo using for teleoperation to demonstrate the use of the mobile base. In this case, we utilize the differential drive plugin. And additionally, we also have an RGB camera and a LiDAR working too. And well, for this teleoperation, you may be thinking yourself, well, how do you teleoperate this? To teleoperate this robot, It's as simple as downloading the package sudo apt get install ROS humble teleop twist keyboard and running ROS2 run teleop twist keyboard teleop twist keyboard. The reason why there's no need to modify any parameters is because the command velocity utilized is the default value that it has within this launch file, that is command file. Additionally, we wanted to demonstrate the movement of the joints within the whole robot, where you see here the joint, the wrist jaw, all the arm, the lift, and the head moving. Which, to use it, you have to write this topic, write this command, in which you modify the name here for the joint that you want to control, and the data value here to according to the position that you want. We developed a specific position controllers for each individual joint within the Gazebo simulation, only because we thought that it was the best manner of representing the movement throughout all the joints for testing purposes. For all the joints, we expanded into the joint arm LO, joint arm L1, joint arm L2, joint arm L3, and joint lift, which are mainly the arm and also the lift. Within the gripper, we expanded joint wrist jaw, the joint wrist fingertip, and the joint finger left. And then within the head, we enabled the joint head pan and the joint head tilt. And well, what are the limitations of this implementation? Probably as developers, that the majority of these people within the school is the joints cannot be controlled through ROS2. What this means to a developer, that if they want to utilize this robot for manipulation purposes or controlling the head, they will either have to create a custom solution bridge between ROS2 and Gazebo Sim, or at the time of I wrote this, I didn't know there was they have properly developed control for ROS2 control, but now that there is to control, is implementing ROS2 control into the stretch robot. Well, how this links to my PhD and my research, since we try to utilize the stretch robot for social navigation approaches, we developed this and we migrated the code from ROS1 using Gazebo Classic into Gazebo Sim Harmonic utilizing ROS2, where we created a custom plugin for pet sim simulation, which I will be more than welcome to give another presentation on that when it comes publicly available. And additionally, we developed an additional custom plugin that provides the ground truth position following the implementation that the Hello Robot did within Gazebo Classic and ROS1. Within that, the ground truth position is not only exported as a topic, but is additionally incorporated into the TFs. And well, how can you contribute? There's different methods in which you can contribute. You can incorporate nav2, which it has already been tested and is currently under development, and it will be published in the future. If anyone feels to publish it earlier, feel free and more than welcome to do so. Additionally, it can be incorporated ROS2 control that it will facilitate the movement of the joints through a ROS2 style, and also implement Move It 2, which it allows for high complexity of movements for example, allowing for pick and place demonstrations. and migrate the implementation they did within the Ignition Gazebo to Gazebo Sim Harmonic. And well, what are the future steps of this work? We plan to utilize this infrastructure to develop telepresence applications within the stretch robot. And additionally, we are planning to develop social robot navigation systems with the stretch robot. And always open for collaborations, so please feel free to get in touch. And thank you for listening. My name is Samuel Millán Norman. I'm a PhD student at Cardiff University. My email is millan-normanes@cardiff.ac.uk. My LinkedIn is Samuel Millán Norman. And I want to give a special thank you to Carlos Agüero and Catherine Scott for making this happen. So yeah, thank you. I'm always open for collaborations, so please feel free to get in touch.
Thank you, Samuel. Thanks a lot for your presentation. Questions? I have a few questions while people think about it. Out of curiosity, I'm not sure if you mentioned the social robot navigation that you do, pretty much like all the research, etc. Is that happening in your lab, or do you go through to some competition? Or because I've seen like RoboCup doing, I think, at home competitions that are maybe a good fit for this.
So we mainly do it as a lab, and we try to do this work more towards publishing papers than competing within entering competitions.
Okay.
For the time being.
Thank you. And out of curiosity, like the version that you mentioned that was available, originally developed by PickNik, that one was already available as a ROS package in the regular ROS build form, etc.
Yes, it was in ROS 2 format, so they migrated it into ROS 2. So it was already working, and it was really helpful also into the migration into Gazebo Sim Harmonic.
So your version was like a contribution into the existing one, or you created your own version based on that one?
We migrated their code into Gazebo Sim Harmonic.
But then, so my question is more, how many ROS packages do exist? The original PickNik one is one ROS package, independent ROS package, and then there's a second ROS package with your migration, or you kind of contributed to the original one?
We developed a different package.
Okay, so there are two now, your version plus the PickNik one. Okay. And when you mentioned that you, obviously you took the version that was in Ignition Gazebo, and then you went through some of the problems. I catch that you mentioned the problem with the inertias, that you had to fix some of the inertia values there because your robot was kind of falling all the time. Did you run into other type of issues besides the inertia problem?
Not really. In some cases, we try to play with the masses, and that led to having some trouble. But by expanding into different links, that managed to sort of tune better the parameters.
Okay, so it was a question of making the code work for newer versions of Gazebo plus fixing those issues well with the dynamics ruler. I see. And another question that I have is like you briefly mentioned that there was some limitations or that you run into some issues, and you mentioned that that controlling your joints from ROS 2, I think you mentioned that could be or was an issue with using the ROS GC bridge. Is that accurate?
Yes, we had a bit of problems with there, and we directly utilize the GZ topics as method to demonstrate the movement of the robot through the simulation.
Okay, and could you, just out of curiosity, could you elaborate what was what did you experience that was not good enough or something? And was it a question of delays, or like what was the real issue? Do you remember?
Yeah, the real issue is that we weren't able. Myself at that moment, I wasn't able to properly implement it. That was my main issue.
Oh, you mean the integration using the bridge?
Yes.
Okay. Yeah, that's fine. Hopefully this is a little bit easier now because we've made a few changes in the bridge. So hopefully it's a little bit more tightly integrated with what a ROS user expects. But yeah. Another quick question, like, did you remember the version of Ignition Gazebo that was used by that existing package? Was it Fortress or?
I cannot remember off the top of my head, but I think it was. Yeah, I cannot remember on top of my head. So sorry about that.
No, that's fine. I just wanted to understand how far that version was from like modern Gazebo versions. All right. Questions? More questions? Jose Carlos, go ahead.
Yeah. Hello. Thank you very much for the presentation. It's really lovely to see how the migration works somehow. My question is more about the time span that you took for the migration. So how much time did it take to migrate from Gazebo to Gazebo Harmonic?
So the time span, it took me to, around. I say to have it a working version took me a month, but to then fine tune and sort of making it available towards sort of being able to make it sort of properly for open source, it took me full 2 months to do it. Sort of cleaning code and sort of making it properly.
Yeah. So that include the plugins that you mentioned that you have to migrate?
Yes.
Okay.
Originally, when we made it work, we utilized the Gazebo trajectory controllers, the joint trajectory controllers that PickNik utilized. But although, since we wanted to showcase the movement of the robot and individual joints, we decided to use to lean towards the position controllers.
Okay. Thank you very much.
More questions? All right. Well, thanks again, Samuel. I think we can conclude a little bit earlier, as usual, than usual our meeting. But if somebody wants to ask any general question about Gazebo in general or any other topic, feel free to do it. Or we take off. Jose Carlos? Yep.
Yeah, I have another question regarding that. So in the physics model, is there so much difference between Ignition Gazebo and the Harmonic? Or is it going to be, is it behaves similarly?
Into the actual physics engine and how it works, we haven't. I cannot give you exact definition into it.
Yeah, I wonder because of the inertia issues. Maybe that's what some differences there.
Probably there's some slight differences between the way that the physics sort of works.
Okay, good. Thank you.
Thank you.
I'll say from from memory, I don't remember any significant like changes. Unless, you know, there might have been changes in the SDF file or something like that during the migration, but in terms of the physics engine, the default is the same. It's still Dart, and yeah, I can't think of anything off the top of my head.
But if I didn't understand correctly, the issue with the falling robot happened directly on the version that you try.
So
Ignition Gazebo, right? That was already happening there.
So initially we tested it in Ignition Gazebo, and that worked properly. And
that worked properly.
Yeah, that was working properly. And then when we transitioned into Gazebo Sim Harmonic, that's when we came with these issues.
Oh, interesting. Because there's a more substantial change from Gazebo Classic to Gazebo, right, in the default physics engine. But from Fortress, if that's the version that you use to Harmonic, it shouldn't be a big change in theory. But if it happened, it happened. All right. Any other question? For Samuel, for anybody?
I'd be interested to know if you know, if you have a model file or something that we can test. Like there shouldn't have been a change in the behavior of the physics engine, especially something like major like that. If you can provide like an SDF file that we can easily test that works in Fortress and fails in Harmonic, that would be awesome.
Okay, I will try to make it available in GitHub.
Awesome.
All right. Thanks again, Samuel. Thanks for the presentation, and thanks everybody for tuning in. See you in the next meeting.
Thank you.
Thank you.